Alright? Now there are two key types of questions that you could be asked in regards to specific heat capacities. So let's do a practice problem for each of those. So I've got them written out right here. So the first one says if you have 50 grams of water initially at 50 degrees Celsius and it absorbs 4,807 joules of energy, what is the final temperature? Now there's two ways that you could basically do this calculation, so let's go through it both ways and we'll see that we'll get the same answer each way. So in both ways we have to start with, so this is the specific heat capacity, and you know it's a specific heat capacity because it gives you a mass. If it does not give you a mass, or you're not solving for the mass, or if the mass is not involved at all, then you just have the heat capacity. Since we do have a mass, it's a specific heat capacity. So we're going to start with Q equals mc delta T. The energy that it absorbed is right there. So that is our Q, 807 joules. Our mass is 50 grams. The specific heat of water is a known value, and that is 4.184 joules per gram degree Celsius. And we can solve here for delta T. So now, basically, we divide both sides by 50 times 4.184, and we solve for delta T. We would get rounded to, so 22.9. I'm just going to round to 23. So 23 degrees Celsius equals delta T. So you could either solve it for this way, and you say, oh, well, a change in temperature was 23 degrees Celsius. You're absorbing energy. If something is absorbing energy, it's absorbing heat, that means. Because remember, heat and energy are the same thing. So it's going to be getting hotter, the temperature must go up. So if we add that 23 degrees that it changed to the 50, because it has to go up, our final temperature would be 73 degrees Celsius. Or what you could say is this: Q equals mc delta T to start again, and delta T can be rewritten, so Q equals mc. Now, and delta T can be rewritten as the final temperature minus the initial temperature. So here we'd set it up 4,807 joules equals 50 grams times 4.184 times, we don't know the final temperature, we're looking for that, minus the initial temperature is 50. And if we were to solve this through, we would once again get a TF of 73. So either way that you want to do it is perfectly fine. If whichever your preference is, just go with that. Another type of question is this. So if we have a 220 gram metal block initially at 160 degrees Celsius and it's dropped into 50 grams of water at 22 degrees Celsius, and the final temperature of the water is 37 degrees Celsius, what is the specific heat capacity of the block? So again, we're dealing with specific heat capacity. So for this, we need to write out the Q equals mc delta T equation for both the block. So this is for the block and for the water. Now, what it can be assumed, so we have a hotter block coming into contact with colder water. When you have a hotter object and a colder object come in contact with one another, heat gets transferred from the hotter object to the colder object. So we can assume that all of the energy that is transferred from the block is the exact same energy that's absorbed by the water. So all of the heat transferred, the Q values, is going to be equivalent because it's all the exact same energy. So if we can say the mass of the block, so I'm just going to give a subscript of B to represent the block. If that equals Q, and that exact same Q, because remember all of the heat transferred by the block is the exact same heat transferred to the water, So this is MW, CW, and delta TW. If this is equal to Q, and this is equal to the exact same Q, they also have to be equal to each other. So you can rewrite it as M sub B times C sub B times delta T equals mass of the water times the specific heat capacity of the water times the delta T of the water. Okay, we know the mass of the block right here. So we've got 220 grams. We are looking for this, right? It's asking what the specific heat capacity of the block is. So we're looking for this value. We are not directly told the delta T of the block, but we are told the final temperature of the water. Now what could be assumed in this problem is that the block will continuously transfer energy to the water until they have the same exact temperature. When the temperature of the two is the same, no more heat transfer will happen. So if we're told the final temperature of one of them, it can be assumed that the final temperature of the other object is equivalent. So going from 160 to 37, that means that the delta T of the block is 123 degrees. The mass of the water is given as 50 grams. The specific heat capacity of water, once again, is 4.184 joules per gram degree Celsius. And the delta T of the water, well, we know that it went from 22 degrees to 37 degrees, so it has to be 15. So we have every single variable except for the one that we're looking for. So I'll break down this into two steps. So let's do 220 times 123, and we get 27,060 times the specific heat capacity of the block equals, so if we multiply these three, 50 times 4.184 times 15, we'd get 3,138. So then dividing both sides by 2760, we get a final answer of 0.115. And again, our units have to be joules per gram degree Celsius. And that would be your final answer.